Hi everyone, welcome to our next video for week 5. Today we're going to talk about hypothesis tests for a single proportion. Just like confidence intervals for proportions, we're using a z-test to run our hypothesis test on a single proportion. So we're back to our standard normal curve. And for the traditional method, we know that our critical values coming from table E or inverse, oh my goodness, Mr. J has typos all over his slide. Inverse norm or inverse normal. Dangers of copy and paste. And the test value is the z-score formula for proportion. So this is something else that we saw when we were looking at confidence intervals last week. If you don't want to calculate the test value by hand, there are function calls in the TI-84 and GeoGebra to find that value. Those are the same function calls we're going to use for the p-value method. So if you're on a TI-84, you're going to press stats test, and you're going to go down to option 5, which is one prop z-test. Hang on just a second. That feels wrong to me. Let's pull up our TI-84. Isn't actually option 4. Oops, sorry. One more. Yeah, it is option 5. Okay. And then on GeoGebra, we're going to use the proportion test. For GeoGebra, it wants the information in a specific order. So it wants the sample proportion, the sample size, the population proportion as stated in your hypotheses, and then the tail, just like our last two function calls. I'm going to go ahead and do 2 examples with you, and then I'm going to leave the last one for you to try. So let's go ahead and jump into our first example. The Energy Information Administration reported that 51.7% of homes in the US were heated by natural gas. A random sample of 200 homes found that 115 were heated by natural gas. Does the evidence support the claim, or has the percentage changed? So first thing, we see that familiar phrasing, does the evidence support the claim? We know if we're testing a claim, we're doing a hypothesis test. And then let's go through and pick out all that information. So the first thing that I see in that first sentence is a percentage. 51.7% of homes were heated by natural gas. I know that proportion is another word for percent. So this is our population proportion, the thing we're testing a claim about. And then it says a random sample of 200. So that's our sample size. Of homes were found that 115 were heated by natural gas. So that's the number of successes in our sample. And then it says, does the evidence support the claim, or has the percentage changed? So looking at this information, I see all of the familiar information for proportions, successes, and sample size. I know that if I divide the successes by the sample size, I'll get my sample proportion. I see a claim, which is that the proportions equal to 51.7. And then I see the alternative, has the percentage changed? So they're telling me my claim is the equal, and my alternative is the not equal, the different. There is one familiar piece of information missing. They haven't given us the level of significance. They haven't given us the alpha value, but we learned that if they don't give you an alpha, assume that it's 5%, 0.05. So we're going to run this test with a 5% significance level. So let's go ahead and work through this. So I'm going to use the p-value method. And I know that because this is about a proportion, I'm running a z-test. specifically for proportions. And we know that that's different than for means. So step one, we identify our hypotheses, null and alternative. This is the claim about proportions, so I should use P's here. And I know that the claimed value is 51.7 or 0.517. This problem was nice, and they were very explicit about the claim being the equality and our alternative being the difference, that not equal to. We also know that this symbol is going to tell us that we're running a two-tailed test. Next step, we calculate our p-value. So to calculate our p-value, we need to run one of those function calls, and I'm going to use the TI-84 for this. So let me erase some of the stuff that's going to be on our computer screen so we can see what's going on here. So I'm in the test menu, and I know that I'm looking for one prop Z test. So what I'm going to do, I'm going to make a note here of the function call that I'm using and all of the information that I'm plugging in. So one prop Z test. The first thing it asks me for is that proportion value in our hypotheses. So 0.517. It then asks for X. Let me scoot this over a little bit. We can see X is 115. And it asks for N, which we know is 200. Then the last thing it asks for is that tail. What does our tail look like? And we're doing a difference. So let's enter that same information in our calculator. Oops. And I'm going to copy down our p-value. So I know on a TI, the p-value is that second number after it gives the alternative hypothesis and the z-score. So our p-value is 0.1007. And that's pretty big. Something that the calculator and GeoGebra are going to do for a two-tailed test, you don't need to worry about dividing that alpha in half. So our alpha is 0.05. We don't have to split it. Instead, what the calculator does is it doubles the p-value. So for step 3, we don't have to do anything to our alpha or p-value. We just compare them directly as they were stated in the problem or were calculated by a calculator. So we want to compare our p-value to alpha. And in this case, 0.1 is bigger than that alpha of 0.05. And we know when our p-value is bigger, we do not reject. So getting 117 people using natural gas out of 200 is not different enough from 51.7% to say that we can reject that statement. For step 4, all we have to do is summarize that. And remember that we're looking at two things. We're looking at, did we reject or not? And then what was our claim? So in step 3, we did not reject, so there is not enough evidence. And then we go back and look at our claim to figure out, are we supporting or rejecting? When our claim is the null, we talk about reject. So there is not enough evidence to reject the claim that And then you fill in the rest of that sentence frame with information from the problem. So we go back and look, and our claim is that 51.7% of homes in the US are heated by natural gas. Okay, I'm hoping that this process feels familiar and we're only getting little tweaks at steps one with the notation and step two with the function call for each of these different hypothesis tests. Let's go ahead and do another one together just to make sure that we understand the process for proportions. So for example, two, it says nationally, 60.2% of federal prisoners are serving time for drug offenses. A warden feels that in his prison, the percentage is even higher. He surveys 400 randomly selected inmate records and finds that 260 of the inmates are drug offenders. At alpha equals 0.05, is he correct? So this is a little bit weirder in that they don't use that familiar test the claim sort of phrasing, but they do make a claim at the beginning, and then they're asking, is he correct? And that applies that we're testing the validity of a statement. So that last chunk of the question indicates hypothesis test, even though it's not that same wording we've seen before. So let's go ahead and go through this and pick off our values. So first, 60.2% of federal prisoners are serving time for drug offenses. That's a percentage or a proportion. So that's our assumed population value. Next, it says a warden feels that his percentage is even higher. That's a greater. So they're telling us that our alternative is a greater than statement. Next, it says he surveys 400 randomly selected records. So that's our sample size. And finds that 260 are drug offenders. So that's our number of successes for this study. And then last, they give us our alphas 0.05. So we have enough information to go ahead and run our hypothesis test. We're going to use p-value again because it's quicker. Because this is a claim about a proportion, we know we're doing a z-test for a proportion. So I'm going to go ahead and do the setup really quick, and then we'll go ahead and work through this. Filling out this format because I know what's coming because we've already run a hypothesis test for a proportion. Once you've done one, the rest should look very similar with just the numbers changing. Okay, so we'll start with our hypotheses. Claim about proportion need P. Our claimed proportion is 0.602. And we're told that he claims that the percentage in his prison is even higher. So that's a greater than. I'm going to default to equals to in my null. If you use less than or equal to, that's also fine. And he's claiming it's even higher. So that's the thing we're interested in testing. Is he right about the percentage in his proportion being higher? So again, we're going to go ahead and pull up our TI-84 and start popping in values. So we're going to go stat test option 5. And then we know we need P naught, so 0.602. We need X, which is 260. And then we need N, which I'm pretty sure is 400, but let's just check. N is 400. And then our tail is a greater than. So we're going to go ahead and enter that in our calculator. That gives us a p-value of 0.0249. And comparing that to 0.05, that 0.0249 is less than. So we definitely reject our null. Okay? That p-value is a little bit less than half of that alpha. So we're firmly in the reject zone. So our last step, we're going to go ahead and write our conclusion based on rejecting the null. Sorry, having technical difficulties here. So first we look at our decision we rejected. So there is enough evidence. And then we look at our claim, and our claim is the alternative. And so we're talking about supporting the claim. There is enough evidence to support the claim that, and then we summarize that claim. So in this particular instance, the claim that the warden is making is that the percentage of prisoners serving time for drug offenses is even higher than 60.2. Hey, so I'm going to pop another example up here. Example 3, a researcher claims that based on information obtained from the CDC, 17% of young people ages 2 to 19 are obese. To test this claim, she randomly selected 200 people in the age range 2 to 19 and found that 42 were obese. At alpha equals 0.05, is there enough evidence to reject the claim? So I want you to take a second, pause the video, try either the p-value or traditional method on a piece of scratch paper, and then restart that video, and we'll go over the solution really quick. Okay. So on the left, you can see that I picked through that problem. I identified that we're doing a hypothesis test. And because I'm given a percentage, I'm doing a hypothesis test for a proportion. So that's a p-value method, z-test for proportion. I identified the population value that's assumed correct, and then the sample size and the sample number of successes. This time I ran the test in GeoGebra. So I used the z proportion test function call, and GeoGebra asks for the sample proportion first. So doing this method, I actually had to calculate that sample proportion. You'll notice I entered it as a fraction, 42 over 200. That prevents any rounding error, and GeoGebra will calculate that decimal when it runs the test. Then it asks for the sample size and the population proportion, and then the tail, which is the alternative. In this case, the claim is that the proportions equal to 17%. So our alternative should be opposite of equals, which is not equals. That is important. We are running a two-tailed test. When I ran that function call in GeoGebra, I got a p-value of 0.1321, which is greater than our alpha of 0.05. When our p-value is bigger than our alpha, we do not reject. So using that information, there is not enough evidence because our claim is the null, reject the claim that 17% of young people ages 2 to 19 are obese. Okay. I'm hoping after these few videos, we're feeling pretty okay about the method. In our next video, we're going to start talking about using a hypothesis test to compare two means or two proportions. If you have any questions about what you've seen so far, let me know via email or drop by my office hours on Tuesday, Thursday, or Saturday. I hope you're having a good week, and I will see you in the next video.